No, I don't usually. I'm not someone who takes courses and classes and things like that because in the past, when I did in college, it didn't really, unless I was really intent on learning, it wasn't very effective. To be forced to do, schoolwork. It's better for people who need to learn the curricula than or to take the curricula to learn the skills and things. But whenever you don't have much reason to learn the skills, it's not going to be as effective in learning the skills. And that's the problem with college and high school and all those things is that unless you can apply what you know, it's not going to stick. And there are a lot of people that will go through courses and just regurgitate stuff they find in the book without actually processing or making decisions or even being able to apply it. And if you don't apply it, then whatever kinds of questions you give people on an exam is not going to be beneficial. I mean, it's just not going to get you the sort of expectation that you're going to remember any of that stuff because even whenever you try to add some creativity to it to permit them to apply it, that knowledge, it may not result in complete assimilation of the information and being able to bring it to reproduce it. And at the very least, somebody who is like that might be able to teach it to other people. If they can't apply it in the real world, they can't make a career of it. They can at best teach it to somebody else, but it doesn't have as much effectiveness if they didn't apply it in the real world, because the person they've taught it to will take it and say, well, it obviously didn't work for you. But that's the risk you take, and I mean that's just what happens. I mean, to you can't expect for more than 15% of your students to retain what you've taught them, because there's a good chance about 90% or 80% of them are just going to forget everything you've ever said in the course. So you're really kind of just shooting for to try to educate a percentage of that, and I mean, that's what you experience in churches whenever people preach sermons, is that the ones who are assimilating it, you can't really know who they are, and it isn't going to come about even if you try to test them on it. There'll be guys like me who will retain a recording in my brain, and over time will start to assimilate the information bit by bit, but was not able to report it on a test, because I wasn't given enough time to assimilate the information. And there's also stuff that I just didn't learn because it didn't really translate well to me why I needed to learn the stuff, that there wasn't much proof given for the application of that knowledge. And when I was in computer science, there was a big concern among the professors that they could not really have courses on operating system design whenever the entire world was dominated by one operating system, and that was Windows. And Windows didn't offer any kind of open source, that didn't offer source code, so you couldn't train a new breed of computer science or people who program to understand how to create operating systems. You could only give them examples of closed source operating systems that were presently available, and how they work, but you couldn't give people the tools to apply the theory, and so it was a major concern whenever I was in college, and that was what drove a good bit of the support of Linux in schools, was that you could then, because of Linux, you could experiment with different kinds of scheduling systems and things of that nature, and actually be able to teach operating system design. Anyhow, what was I originally coming in here to record? Hey, that's a big problem, with me. Is I start out, I come in here, I'm going to go record something. Oh, the idea that every step forward that we take with technology is a step back. The internet has brought about their capacity to make all the things we need, or the things that used to be hard to get access to, accessible, instantly accessible. So any needs you have, it's very easy for you to find the parts to complete the designs of things that would otherwise just sit around, not being very useful. However, the cost that this has taken on is that we've lost a lot of the people who could maintain existing purchases, maintain the contraptions that we buy, because the contraptions are largely made of moving plastic parts that will fail. And there's not very many things made anymore that are made of metal, that have that are designed to have integrity. And so they got very little integrity, and because of that, we just tend to keep repurchasing stuff, not ever really knowing so much about how things are made. But that's turning around as a result of, documentaries like Bre Pettis and his Make show, to help people to understand electronics and things of that nature. I don't know if he's still doing that stuff. It's been a while since I've watched one of his shows. But, there is those support channels for people to learn the skills of that support, that those support services that people maintained in the past, because solutions were inaccessible, and they would require mailing away for parts, and the parts may have never gotten to your door, and so there would be people around that could retrofit, or come up with solutions that would kludge something to work, and in some cases such people would be able to actually augment the design of the original thing, and do it for without ever really giving it much concern. And one example of that type of person is Dana Carvey's brother, Brad Carvey, who is the humblest guy you could probably ever meet. I've met him personally, and he really does he knows his capacity and his value of his skill in the technical field. He just doesn't. He takes the kind of the Swedish approach to it, that you just don't, even though you're talented, you just don't try to prove it to everybody. That you kind of let other people learn that about you. You don't try to burn it into them how special you are. And so he's got merit. He's got Academy Awards. Both him and his brother got Academy Awards for completely different things. And but knowing Brad, I doubt that he would point to his Academy Award bringing anybody into his house, because he's just, if you've ever met him, or you wouldn't really even have to know him, you could know people that know him. He just is not somebody who really throws stuff in people's faces like I would. Ton Rosendal's also the same kind of person. He does. He's got great skill and ability to create very complex software that works very simply, but he doesn't throw it into the face of everybody to show how great a person he is, and because he understands that, you know, that you know, that can be a stigma, and it was a stigma for a while in the early part of Blender's development for him to be able to relinquish control of the sources so that other people could come in and contribute. And I think it wasn't for ego that he did it. He was really doing it. Part of it was to um, try to create more benefit, because he believed that if it was backed by money, he probably would have been able to develop it into a better product. And he was unsure about what open source would really do. He wasn't convinced, and even now he doesn't develop like a completely open source project. He retains some control, but he was, I think what I believed of him was is that he was more concerned about people's interpretation of his code, and he didn't like that it had like Dutch comments through it, and that it had structure, but it was but it's not like C++. It was not any formal object-oriented language. That he was using functional based approaches and object-oriented approaches together, you know, just to get things done. Because that's when you're developing software, the best approach is to just get things done, and but with an eye towards proper design, and also an eye towards trying to be productive, trying to get things out that people can experiment with, so that you can then determine what features are necessary and what features aren't. And in the early stages of Blender, he even though there were lots of people that would complain because they didn't find a button to do this or that, he would rely upon guys like us to try to communicate to these people who were not novices that such buttons are not necessary, because you can do the same sort of thing with other features that already existed in the software, and that it was just a matter of being able to translate their needs. And so that's the purpose of support, is to listen to the users and to find solutions for the needs that they have, because they don't really know what to call what it is that they need. They have a need for something. They have in mind what it is, but they don't know what to call it. They don't know if there's a name for it. They don't understand they don't understand the field. They don't understand the technology enough to really know how to get from point A to point B. And to make it beneficial to both of you, you could provide a service for money. But some people you probably wouldn't want to do that with, because they wouldn't be able to really pay you back. And in such cases, you'd probably come up with tutorials. And the tutorials are a great way of dealing with that problem. But I've learned more in working with software by getting getting access to not so much tutorials, but getting access to source code, getting access to being able to work in an interface that had an ample amount of intuitive features by which I could glean some understanding of as to how to use them. However, with Blender, it was very difficult because a lot of the buttons were cryptic, and you didn't really understand that some of them were inspired by Dutch words and things of that nature. And so the only way I could really realize what features existed, and even there were even features that were not represented in the interface that were kind of modes inside of the interface, behind the interface. An example being that you could use a texture to apply you could use a texture on a height map by the use of the putting the texture in a particular place on a layer. I think on a texture in a texture cell for a material. If you put it in a particular cell, and I think it was the last cell, and then you went and applied the vertex deformation, the noise deformation, it would, instead of using noise, it would use the texture to deform to apply a kind of a magnetic effect to the vertices in a plane. And so it was a way of creating quick fractal-like mountains and terrain. But it isn't described anywhere in the interface, and it existed in Blender, I think, from the very beginning. So he had some stuff that didn't have buttons that were just understandings, and I would have to communicate that to users who would see that kind of stuff as not being very intuitive. And I agreed with that, but there were other things that have been lost along the way. I think this has been lost. I haven't checked it out in the current Blender, and that is the ability to constrain to an axis by performing a particular gesture, and that is you move your mouse from right to left or left to right, and it will pick the nearest axis to constrain to, and that's what permits people who use Blender a lot to work in orientations that are beyond turntable orientation. There are people that work in Maya who work upright. They don't work on models unless they rotate the model to get access to things that are underneath or inside, or in certain angles. But in Blender you can do it, and to somebody who doesn't understand Blender, it can look very odd and awkward how people will align themselves to a surface plane and model in Blender whenever it's like they're just at a complete arbitrary angle, and they don't work in turntable. It's called spaceball mode if you use Maya, but I'm not sure. I think I remember how it is that you get aligned to a particular polygon. You select several vertices or a cloud of vertices. They'll pick the best possible alignment to that cloud. It'll pick a plane, and to align yourself with the plane, I think you use the star on the numeric keypad. and that will align you to that polygon or whatever. And then in that you could say add faces, like if you were working on a a merry-go-round, a carnival merry-go-round with the horses and stuff, and you wanted to put um, the faces, the what is it? They're called the there's a name for it. It's like facade, but it's got a different. It's a different name. Um, anyhow, to put faces and mirrors and stuff on the inside that are at a certain angle to the merry-go-round. Um, to work on stuff like that in a turntable interface is very difficult. It's a lot easier to deal with something like that using an arbitrary modeling system. And you could do that in Blender, and you could do constraints to axes um, just by doing gestures in relation to what you believed was the desired axis to constrain to. And it would be whatever's the nearest, and that's a whole lot easier than specifying your axis, than knowing that axis and specifying it, and specifying that you want to constrain on it. So much easier to do a gesture and let the computer figure out which axis you mean. You mean. Anyhow, I'm going to cut this video short because things that get to be too long, people just don't want to listen to them.